In this video, we are going to learn about cardiac cycle. Before we do cardiac cycle, let's go over heart sounds. Let's see what happens in the heart, what happens in the cardiac cycle. So blood, it comes in the atrium on the left and the right side, and the atria, they fill. So this is the relaxation phase or the diastole of the atria when they are filling. So when the atria are relaxed, just remember that ventricles, they are contracting. Ventricle are not waiting for atria to be done, and they are also resting when atria are resting. So the blood is coming in the atria, and when the atria, both on the both side, the left and the right side, they fill up, the atria, they contract. When they contract, these valves open. These are atrioventricular valves, both on the right side and on the left side, they open. And when they open, the blood, it gushes into the ventricles. So blood is forced into the ventricles. Now when the blood comes in the ventricles, the volume in the ventricle, it increases, and the ventricles, they start to contract. And when ventricles start to contract, we call that ventricular systole. Systole is contraction, diastole is relaxation. So when these ventricles contract, these AV valves, they are closed. And these thread-like things, they are known as chordae tendineae, and these are papillary muscles. They also contract, and their contraction, it prevents these the cusps of these valves from everting into the atria. So when ventricular systole begins, the AV valves, they close. And when the AV valves on both sides, the sides, they close, we hear the first heart sound, lub. Okay. So the first heart sound is, it happens at the beginning of the ventricular contraction or ventricular systole, when the AV valves, they close. Mitral valve closes a little microsecond before the tricuspid valve, but our ears, they hear only one sound. I mean, the time difference is very minor. So then what happens, that the ventricle continues to contract for a while, and when the pressure rises, then that raised pressure, it opens these semilunar valves. Semilunar valves are present between the ventricle and the great vessels. So on the left side, it is between the left ventricle and the aorta, and on the right side, it is between the right ventricle and the pulmonary trunk. So this opens the semilunar valves, and blood is pushed into the aorta from the left side and into the pulmonary trunk from the right side. So when this happens, then after that the ventricle, it relaxes, which is known as diastole. So when the ventricle relaxes, the blood, it tries to backflow into the ventricle. But because of the shape of these semilunar valves, these valves, they close. The cusps of the semilunar valve, they close. And when these valves close, we hear the second heart sound, dop. So the second heart sound, it happens at the beginning of the ventricular relaxation or ventricular systole, and it is due to the closing of the semilunar valve. So both of our heart sounds, the first heart sound and the second heart sound, they happen when the valves close. We do not hear in a normal healthy heart with healthy valves, we do not hear anything when the valves close. In certain diseases, when the valves are not healthy, then those sounds become visible, but those are not normal heart sounds. So the normal heart sound which occur in healthy condition, lub dub. Lub is the first heart sound due to closing of AV valve, and dub, the second heart sound, is due to closing of the semilunar valve. So when the after lub dub, when the semilunar valves have closed at the beginning of the ventricular relaxation. So we can say between two heart sounds, the heart is relaxing, right? So the ventricle, it is because then again this AV valve is open and ventricle, they start to fill. Okay, now let's look this up. We have two sounds, lub dub, associated with closing of heart valves. First sound is closing of AV valves at the beginning of the ventricular systole, ventricular contraction. Okay, just remember that try to imagine that the ventricles have filled up and now they contract. When they start to contract, the AV valves, they are forced to be shut. So the AV valves, they close between the ventricle and the atria, and we hear the sound lobe. And then the second heart sound is the closing of the semilunar valves. When do they close? When the ventricles, when they contract, they push the blood into the vessels, and then ventricles relax. When ventricles relax, the backflow of the blood, it causes these semilunar valves to close, and at this time we hear dope. Okay, so between one lobe dope and the second lobe dope, it indicates that the heart is relaxing. And then a mitral valve, it closes slightly before tricuspid, and aortic, it closes slightly before the pulmonary valve. So but we hear only one sound, lobe dub. But we can, if I want to hear what's happening at the tricuspid valve, and I want that sound to be prominent, then I put my stethoscope where I know that tricuspid can be heard better. And if I want to listen to the mitral valve, I put my stethoscope where the mitral valve can be heard better. So this figure will explain what I just said. So this is where we can auscultate the aortic valve. It is in the second intercostal space at the right sternal margin. This is right. And then this pulmonary valve, it is on the left sternal margin in the second intercostal space. So this is where we place the stethoscope if we want to hear the pulmonary valve. And then the mitral valve, it is heard at the apex. Apex is in the fifth intercostal space in the mid-clavicular line. This is clavicle, the collarbone. So we take, and from the middle of the clavicle, we draw a straight line. And then in the fifth intercostal space between rib 5 and rib 6, it is there where we can hear the mitral valve. And this is the apex beat of the heart. And then for the tricuspid valve, again in the fifth intercostal space at the right sternal margin. Okay, so you know the sternum. So these are our 4 areas of auscultation for the heart sounds. Now let's start the cardiac cycle. First, let's go over these terms. Systole, period of heart contraction, the heart is contracting. Diastole, period of heart relaxation. Relaxation means that chamber is filling. Now, what is cardiac cycle? Blood flow through the heart during one complete heartbeat. It includes atrial systole and diastole. It means atrial contraction and relaxation. And they are followed by ventricular contraction and relaxation. Okay. Then cycle presents series of pressure and blood volume changes in the atria and in the ventricle. So we will see during one heartbeat how the pressure changes in the atria, how the pressure changes in the ventricle, and then we will also see how the pressure changes in the aorta. So on the cardiac cycle, usually they have put on the left side of the heart, but the same things are happening on the right side of the heart, but only the pressures are lower. And then we also try to fit in the ECG, that when a ventricular systole is happening, what will we see on the ECG? When ventricular diastole is happening, what will we see on the ECG? So we get everything on one chart, and we call it cardiac cycle. So we can see everything at one glance, what is happening where. Okay, so before we look at the cardiac cycle, we might get overwhelmed. Let's start slowly and let's go over this figure. So this is our heart, and these are the atria, and these are the ventricles. So cardiac cycle, usually it is made on the left side, but the events, they're happening on the both side. So let's look at the ventricle. Let's consider what is happening in the ventricle. So this curve over here, this is left ventricular pressure curve. This is the pressure from 0 to 120 millimeters of Hg, and over here is the time. And now see what let's see what's happening in the ventricle. So in the ventricle, the blood, it is coming in from the left atrium, and in the left atrium, at the end of the phase when the ventricle has filled, then the atria contract and they push all of the blood into the ventricle. Now once the blood comes in the ventricle, the volume of the blood in the ventricle, it increases, and the ventricle, they start to contract. Contraction of the ventricle is known as atrial systole. So at the beginning of the atrial systole, or the contraction of the ventricle, this AV valve closes. When this AV valve closes, we are at this point. At this point, the AV valve closes. This is where I have put my pointer. This is the point where the AV valve has closed. It means that this phase before the closing of the AV valve, this is where the atria are contracting. So in cardiac cycle, we start reading from this point where the AV valve closes. So let me go over this again. So at this point in this phase, the atria contracts, and then the AV valve, it closes when the ventricular contraction starts. At the beginning of the ventricular systole, the AV valve is closed. And now for a little while, what happens, that the aortic valve is not open yet. This valve, to the aorta, it is closed, and the AV valve is closed. But the ventricle, it keeps on contracting. As due to that contraction, the pressure keeps on building, and this is going up. This is, the pressure is rising. So this is known as isovolumetric contraction, because the ventricle, it is contracting in this phase, but the volume is the same. Isovolumetric, iso means same, volumetric, volume, so same volume contraction. So then because both of the valves are closed, no blood is coming from this valve, and this blood is not leaving from this valve, but the ventricle is contracting, and the pressure is increasing. Then at this point where I have my pointer, this aortic valve opens. This valve opens. Now the ventricle, it pushes the blood, it keeps on contracting and pushes the blood into the aorta, and we get this curve. And then at this point, the ventricle starts to relax. So now the wave of action potential has traveled, and the depolarization has happened. That depolarization led to the contraction of the ventricle, and now the repolarization has set in, and at this point the ventricle, it relaxes. When the ventricle relaxes, the blood in the aorta, it tries to, because the pressure decreases, so the blood tries to flow back into the ventricle. When it flows back into the ventricle, at this point the aortic valve, it closes. So over here the aortic valve, it opens, over here the aortic valve, it closes. And now at this stage the aortic valve is closed, and the atrioventricular valve, it is also closed at this point. So the pressure, because of the relaxation, the pressure in the ventricle, it falls down. This phase is known as isovolumetric relaxation. The ventricle is relaxing, but the volume is the same. It is not decreasing because both of the valves are closed. Then at this point, this atrioventricular valve, it opens again, and blood starts to pour in from the atrium in the ventricle, and then this line will slowly start going up till we reach here where the atria will contract, and all of this cycle will be repeated. So this is in one heartbeat what is happening. So this is about the left ventricular pressure. Now let's see what is happening in the ECG, right? Because we already know that in the ECG what is happening in this phase. I said the atria are contracting. The atria contract, and then at this point the ventricles start to contract, and the AV valve, it closes. So this part, it corresponds with the P wave. P wave in the ECG is due to contraction of the atria. And then at this point, the QRS happens, right? Because QRS, it comes in, this wave comes in when the ventricular contraction starts, right? And then over here, when the ventricles relax, we have this repolarization of the ventricle. So this is how ECG corresponds to this. Now let's see what is happening to the volume in the left ventricle. So this is another curve, because when we look at the cardiac cycle diagram, these curves, they have put all of the curves together, and it is easier to see everything at a glance what is happening in a single heartbeat. Okay, now this is volume, left ventricular volume. This is ml and this is the time. Okay. So what happens that in this phase, when the atria contract, the volume in the left ventricle, it increases, right? And then over here the AV nodes, they close and the ventricle, it starts to contract. So isovolumetric contraction. So in isovolumetric contraction, this gray bar, this volume is the same. There is no change in the volume, right? This gray bar is the isovolumetric contraction. And then over here the aortic valve, it opens, and now the volume is, it quickly comes down because it is going into the aorta, right? So the volume, it comes down. And then here in this gray bar we have the isovolumetric relaxation. So at this point the aortic valve is closed, and also the AV valve has not opened yet, and the ventricle, it keeps on repolarizing and relaxing, and we get this isovolumetric relaxation. For in the gray bar, see there is straight line for the left ventricular volume. The volume is the same. And then at this point the AV valve opens, and now the volume is starting to going up. And when the volume will reach certain level, and the atria will contract, then the ventricle will contract, then this pressure curve will happen again. So this is volume in the left ventricle going up. So now let's look at this figure. I just wanted to develop your taste for this so you don't get overwhelmed when you see this. So this figure is actually very simple and very interesting. It puts everything together. So let's look at these lines. So the green line, it is telling us about the pressure in the aorta. Okay, so the green line is about the aortic pressure. Then the red, pinkish line or the reddish line is about the atrial pressure. And then this blue line, this is telling us about the ventricular pressure. So let's go over this. Let's start what we have already learned. We are going to start at this point, right? So this is the point. Now let's see what is happening before this point. So this red line, this is atria. Okay, they have made it. This red line is atria. So at this point the AV node is either going to open or close. So these four circles are where the valves are opening or closing, and they have written here that where these lines are crossing each other, those are the points at where the valves either they close or they open. So let's start, because we already went over the pressure curve of the ventricle. So before this AV node, before this AV node closes, what happens? This is atria, and this atria, it contracts, right? So there is atrial contraction, and all of the blood is pushed into the ventricle. And then this AV node closes when ventricle, it starts to contract. So over here our ventricle is contracting and this AV node has closed, right? Now for a few microseconds, very little, there is isovolumetric contraction. It means the ventricles are contracting, but because this semilunar valve or the aortic valve is not open, the pressure builds but the volume stays the same. So iso means same, volumetric means that the volume is the same. Isovolumetric phases, we have two isovolumetric phases. This is known as isovolumetric contraction. The ventricle is contracting, and when certain pressure builds over here, the aortic valve, it opens, right? Now when aortic valve opens, the ventricle with pressure, it pushes the blood into the aorta, and then at this time the pressure in the ventricle, it decreases, the ventricle relaxes, and the aortic valve, it closes at this circle, right? And then the ventricle goes into this phase. This is known as isovolumetric relaxation. So because the AV valve, it is still not open, it is closed, so the ventricle keeps on relaxing. The volume remains the same, but the ventricle keeps on relaxing the muscle. So this is known as isovolumetric relaxation. And then at this point, the AV valve, it opens again. Now blood starts to pour in, and slowly the volume of the ventricle, it will go up. Alright, so this is what is happening in the ventricle. Now let's see simultaneously what is happening in the aorta. So at this point in the aorta, right, the aortic valve opened. Now we are going to see the green line. So when the aortic valve opened, the blood from the ventricle is pushed into the aorta. The pressure in the aorta, it goes up, right? And then over here, the aortic valve, it closes. So for this notch is because the blood, it tries to push against the aortic valve, trying to get back into the ventricle, but then it goes away. So there is a dip, right? And this is due to the aortic valve. When the ventricular pressure drops below the aortic pressure, blood in the aorta rebounds against the closed valve, causing the pressure to rise briefly as a dicrotic notch, right? And now the pressure in the aorta is going slightly down because the blood is moving forward. So this is our aortic pressure curve, and this is how it fits in the cardiac cycle. And this is what is happening in the aorta. Now let's see what's happening in the atria. So over here the atria contracted, right? And then the AV valve, it closed, right? Now the AV valve is closed, and I'm looking at the pink line. Now the atria, the blood is coming from the vessels, right, from the veins on the right side and from the pulmonary arteries on the left side, and this keeps on increasing here over time. And this is when the AV valves, they are going to open and the blood is going to go into the ventricle. So why is this thing? Because when the ventricles, they contract, the atria feel a little pressure too, right? The blood is coming in the atria from the veins, and it also it gets a little bit of this uprising here. And then over here AV valves open, and now the pressure in the atria is decreasing. Now let's look what is happening to our. So this is when the AV valve closes. This is when our first the closing of the AV valve, it gives our first heart sound, and the closing of the semilunar valve, it gives us the second heart sound. So this is where our heart sounds, they are going to fall. Now let's look at this. We already went over the ventricular pressure curve, and then we went over the aortic pressure curve, this green one, and then the atrial pressure curve, this pink one. Now let's see how ECG, it fits in this cardiac cycle. What changes will we see in the ECG? So in the ECG, we know this is where we always start reading the cardiac cycle, when the AV node, or the not the AV node, the AV valve, the atrioventricular valve, it is closed. It has closed because the ventricular systole has started, and we know before this the atria contract. When atria contract, we get PE wave, right? Then at this point the ventricular contraction starts and we get QRS, and at this point the ventricle, they start to relax and we get T wave, right? So now let's also see what is happening in the volume in the left ventricle. So again we start at this point. The ventricle contraction has started and the AV valve has closed. So over here, this is the phase of isovolumetric contraction. It means the AV valve has closed and the aortic valve has not opened yet, so the volume remains the same. This tan bar, it represents isovolumetric contraction, and then at this point it will come here. At this point the aortic valve opens, and so the volume in the left ventricle, it decreases till it reaches this point. At this point the aortic valve closes, and the ventricle continues to relax. So now this tan bar is the isovolumetric relaxation. So the volume remains the same in this phase. And then at this point, the AV valve, atrioventricular valve, opens, right? It closed over here, but it opens over here. And now the volume in the left ventricle has started to increase because the blood is coming in from the atria. So this is cardiac cycle, and it is not complicated. If you understand it, it becomes really easy, and we can see all of the mechanical events which are happening in a single heartbeat in the heart. Now let's go over the blood flow in the heart. So this is our cardiac cycle. We have 4 phases, right? So this is the ventricular filling phase. What is happening in the ventricular filling phase? So there is a passive phase, and then there is atrial contraction phase. So in the ventricular filling phase, the blood is coming in the ventricle, right? The ventricles are getting filled. So in the passive phase, the blood is just flowing in from the atria to the ventricle, and then atrial contraction happens. So that is like the active phase. The atria, they contract and they push all of the blood into the ventricle. Then the AV valve close when the ventricles, they start to contract, or when the ventricle systole begins. And so we call this phase number 2 isovolumetric contraction phase. So in this phase, the ventricles, they are contracting, the pressure is building, but the aortic and the pulmonary valves, they are not open yet. So blood is trying to move towards those valves, pushing goes on those valves, but they are closed. Then when the pressure increases, these semilunar valves, the aortic and the pulmonary valves, they open, and then the blood goes into the vessels. So this is known as ventricular ejection phase. And then we come to the isovolumetric relaxation phase. So now the heart, it is relaxing, the ventricle is relaxing, and because of that relaxed ventricle, this aortic and the pulmonary valves, they close, and for a little while the ventricular relaxation phase keeps on happening till the AV valve, it opens again. So these are the 4 phases of the cardiac cycle. Now let's quickly go over these slides. They have the same points we have already discussed. So what happens? The ventricular filling, which is mid to late diastole. Diastole means when the ventricles are relaxing. Ventricles fill when they are relaxing. So what happens? The pressure is low. In the ventricle, 80% of blood passively flows from the atria through the open AV valves into the ventricle from atria. And the semilunar valves, they are closed. And then atrial depolarization, it triggers atrial systole, the P wave. Atria contract, pushing remaining 20% of the blood into the ventricle. And then end diastolic volume, we have to know this term. This term will be used again and again. It is the volume of blood in each ventricle at the end of ventricular diastole. It means when the ventricles have filled as much they were supposed to fill. So the volume at the end of the diastole, or at the end of the filling of ventricle, is known as end diastolic volume. Now after that, the depolarization happens. The depolarization wave, it spreads on the ventricles, and we get QRS wave in the ECG. And then atria finish contracting and return to the diastole, while ventricles, they begin systole. So this is our phase 1. And then what happens? Isovolumetric contraction is our phase 2. The atria, they relax, right? Atria have done their job, and now the ventricles begin to contract. Rising ventricular pressure causes the closing of the AV valves. Then isovolumetric contraction phase is split second period, when the ventricles are completely closed. All valves are closed. Volume remains constant. Ventricles continue to contract. When ventricular pressure exceeds pressure in the large arteries, semilunar valves are forced open. Pressure in the aorta reaches about 120 millimeter of mercury. Then after isovolumetric contraction phase, there is ventricular ejection phase, and after that we have isovolumetric relaxation or the early diastole. So following ventricular repolarization, the T wave ventricles they relax. Now there is a term end systolic volume. What is this? Volume of blood remaining in each ventricle after systole. So after the ventricles they have ejected the blood into the aorta or into the pulmonary trunk, a little amount of blood it remains in the ventricle. That is known as end systolic volume. It means the volume at the end of the contraction. Ventricular pressure drops, causing backflow of blood from the aorta and the pulmonary trunk that triggers the closing of semilunar valves. Ventricles are completely closed chambers momentarily, and this is referred to as isovolumetric relaxation. And then in the aortic pressure curve, we saw there was a dicrotic notch. Why was that? Closure of the aortic valve raises aortic pressure as backflow rebounds off the closed valve cusps, and this is referred to as dicrotic notch. So there is kind of a dip. Atria continue to fill during ventricular systole. Okay, so when the ventricles are contracting, atria are not just waiting for them to contract, they continue to fill. So it is like ventricular systole is atrial diastole phase or atrial relaxation phase. So they continue to fill during ventricular systole, and when atrial pressure exceeds ventricular pressure, AV valve open and the cycle begins again. Heart beats around 75 times per minute. Cardiac cycle lasts about 0.8 second. Atrial systole lasts about 0.1 second and ventricular systole 0.3 second. Quiescent period is total heart relaxation that lasts about 0.4 second. So this is there is a video in your Pearson text. I would want you to watch that video.